Today we're going to talk about composition of functions. I'd like to draw your attention to something we did earlier. F of x equals 3x plus 2. F of 5. Hunter, what should I do?
Put it in there.
I need more specifics, please.
Put the 5 in place of the x.
Awesome. Excellent answer. Put the 5 in place of the x. So 3, and now instead of the x that I saw above, I put in a 5. And then don't forget about the plus 2. That gives me 15 plus 2, which is 17. This is because we learned earlier that we talk about things in function notation f of x instead of y. So the thing that comes in the parentheses just says, shove that in there whenever you see that thing. So now what I want to talk about is, okay, great. What if I said this instead? F of triangle. Do it. Write an answer on your paper. You have 15 seconds. See, to me, this really tells me whether or not you have any idea what's going on. Because you should have got 3 triangle plus 2. I have no idea what that triangle was. But the idea of f of something means shove it in there for the x. So instead of the x, I have a triangle. That's it. That's the whole idea. And composition is the same thing, except today, composition is where we put one function in for the x of another function. So like our triangle, we're going to take a whole function and shove it in there for the x. That's the idea for today. Put one function in for the x of another function. That's the composition of functions. F of 4 is something that we've been doing before. F of 4 says look at the f function and put a 4 in everywhere you see the x. So up above, here's the f function. I'm going to go negative 2 times 4 plus 7. Or in other words, negative 8 plus 7, which is negative 1. What happened is I took the 4 and I shoved it in to the x. Grant.
In one of these problems, does the f mean anything that you solve for f?
In the second one, in B, it says g of negative 3. That means I take this negative 3 and wherever I see the x value, I plug it into the g function. So here's negative 3, I plug it in over here. A lot of people will probably get the wrong answer because they don't know how to use parentheses on their calculator. It actually is negative 3 in a parentheses squared minus 2, which is 9 minus 2, which is 7. And many of you will get negative 11. So be careful when you put this in your calculator. Whenever you're squaring something in your calculator, you need to put a parentheses around it. Otherwise, it doesn't realize that and it's doing the wrong order of operations because you told it to. So watch out. This stuff that we just did is really not composition of functions. That's just function notation and how to plug it in. The next few things that we're doing are composition of function. And basically what it is the following. Look at, actually let me say one more thing. I want to go back up to our notes where it said composition of function. I want to write one more thing. I want you to write this down underneath all the other stuff you wrote. Do inside first. Do the inside first. That's what I want you to write down. Bless you. Now, the reason I say that is we look down below here. I see this G3. See how it's on the inside? There's F and there's G. So I see G3. What that means is look at the g function. There is a g function, and when I look at it, I'm going to put in a 3. So g3 is 3 squared minus 2, or in other words, 9 minus 2, which is 7. So the red junk on the inside is g3, 7. Oh, that makes my life easier, because really, this wasn't saying f of g3, it was really saying f of 7. So that makes my life easier. So now I can just go, oh, I want f of 7, because this g3 thing was really a 7. So that's nice. So now I can go, okay, I want f of 7. So I go to the f function now, and I go, oh, there's f up here on the left-hand side. That's really like negative 2 times, shove in the 7, and then add 7. When I do that, my answer is negative 7. This is the final answer, negative 7. So f of g of 3, the answer is negative 7. Let's try another one. Let's look at h of negative 2. So h of negative 2 means, let's look at the inside stuff first, that h of negative 2. It means look up into the h function over here and shove in negative 2. So h of negative 2 equals parentheses negative 2 plus 1 parentheses squared. Or in other words, negative 1 squared, which is 1. So the inside junk, the h of negative 2, when I plug in the number and find out what it is 1. And I really want g of that number. So now whatever I found out gets dumped in for the g. So I really want g of 1. So I look to the g function up above, and that means I have 1 squared minus 2, or in other words, negative 1. And that's my final answer. So composition means really you're shoving a function into the other one, but what we're doing is we're deciding to take it in steps. We're doing the inside thing first, and then the outside thing. It's 2 steps instead of just 1. Down below, I'm going to skip F because it's really the same as the other ones. Down below, there's something different about G and H. What's different about G and H? Jeff? There's a variable instead of a number. So this is kind of like our triangle. But we don't do it any differently, really. So if I look at the inside stuff, G of A, the G of A means look inside the G function. So the G function was something squared minus 2. So when I do this, I have G of A equals a squared minus 2. Or I can just write it as a squared minus 2. I don't really need a parentheses. And then I want to take that answer, all of it, all of the a squared minus 2, and I want to put it into the f function. So I look at the f function, and as I look at the f function, I know that the f function was, so I want f of a squared minus 2, and that means I have negative 2 times a squared minus 2, but don't forget at the end of the f function there was a plus 7. So this stuff that we were talking about, this a squared minus 2, went in for the variable, the x. And then if I write down what that means, don't forget that when you see a number on the outside of a parentheses, that means you're using the distributive property. So you have to multiply that negative 2 times the a squared and times the minus 2. So this is really like saying negative 2a squared plus 4 plus 7. Or in other words, negative 2a squared plus 11. This is my final answer. Letter E is a little bit weird because the minus 3 is on the outside, so let's look at the h of x plus 2. So as I look at this h of x plus 2, I go back up to the h thing, and inside where I see the x, I'm going to put x plus 2 now. So h of x plus 2 itself, just by itself, without the minus 3 thing, would be parentheses x plus 2, that's what I just plugged in. Oh wait, there's a plus 1 more, right? And it's being squared. Now if I want to, I forgot about that minus 3 here on the end, right? So should I put that on the end now? Is that all right? I'll put the minus 3. So there's minus, oh, that's a bad color. Minus 3. So I need to put minus 3 because that was h of x plus 2 minus 3. And really what this is saying is that I want to simplify that, and then when I get done, then I want to take away 3. So if I take that peachy colored stuff, it's really saying x plus 3 squared. And then don't forget about your minus 3 on the outside, Alexis. That's what it's saying. Now if you FOIL this stuff out, I'm kind of running out of room, as you can see. So I'm going to kind of take this stuff down below over here. If I FOIL out this thing, that means if I take the x plus 3 times the x plus 3 and I FOIL it, I will end up with x squared plus 6x plus 9. That's what happens when I FOIL that. And then I also had that minus 3. So I reversed my colors here. And then the final answer would be what you get when you simplify all that, which in this case would be x squared plus 6x plus 6. So in the pink, or fuchsia color, whatever you call that, that's my final answer after I've simplified everything. So the big idea in E is that you're going to plug something in, and then after you get done plugging it in and simplifying it, take away 3 at the end. That's what they're saying in that one. Okay? Is that we have, in number 2, 2 lists, an F list and a G list. And what you need to understand about this is whenever they give you things in lists like this, these ordered pairs, we used to talk about ordered pairs